So, last time on hypothesis testing, I won, and I won in a landslide. We were playing a game as a recap where I had a pack of cards, and I said they were fair, the same number of black and red cards, and 15 cards, 15 students, each took a card out with replacement, and 4 came out red and 11 came out black. So I won. But was the pack fair? Well, I said it was fair. I'm not going to let you see the pack. So can we use statistics to see whether we would accuse me of cheating? Is it sufficiently unlikely that a fair pack would end up with only 4 red cards coming if it was fair? Would we actually say there's evidence to say that it is not fair? It's also worth noting at this point that, of course, we could get 411. We could always get just by chance. That could happen. But how unlikely is it? And that leads us to our first hypothesis test. 15 cards are chosen at random with replacement from a pack of cards. It is found that only 4 are red. Test at the 5% level whether there is sufficient evidence the pack is biased against picking red cards. Now, this is called your significance level. So, firstly, in the question, there's no like x's, there's no binomial distribution set up, we don't know what p is, so I need to set up a lot of these things. So I'm going to let the binomial distribution x be the number of red cards chosen. And I'm going to now set up my hypotheses. So x is, in this case, binomially distributed. There are 15, and the probability here I'm going to put is 0.5. Well, that's actually what we want to question. Is it 0.5? So, but the moment that's what it would be if the pack was fair. So we're testing, is there evidence to say that it's not fair? Well, this brings us to the first section, and that is our hypotheses. So the first thing we're going to write is H0, and that is that P is equal to 0.5. Now, it's worth me just saying what this means. This is called the null hypothesis. This is that the thing that we've got there, the thing that we expect is actually true, that the pack is fair. This would be that the pack is fair. The thing we want to test it against is the alternate hypothesis. And the alternative hypothesis is H1, and that is that P is not 0.5, but in this specific case, we want to see is actually the probability of getting a red card less than 0.5. And that is the thing that we want to test against. Okay, in this next stage, now we need to also note that in the question, we haven't said what P is. So it's really important that we always say what that is, where P is the probability of picking a red card. Okay, this is our setup. So I'm going to write that there and very clearly say this is the setup of a hypothesis. Actually, it's including that bit at the top. So it is this part, and you must always write this first. It's the setup. We've taken the question and we've kind of set up what we're going to do. The next thing that we do is we're going to do the actual maths of it. Right, so firstly, there are a couple of methods of doing this. The first one I'm going to do now is we're going to find using a critical region. So we're going to find the values that would mean, we would go with P not being 0.5, i.e. we would be rejecting that H0 is true and going with H1. So we're going to find the critical region, i.e. we're going to find the values for which we think that that the pack of cards is suspicious. and there are other ways of doing this. We want to find it at the 5% level. So actually, if I remind you from the previous thing, what we're going to solve here is we're going to find that k value. We're going to be basically solving this question. What is the value of the largest value of k? So that's what we're going to be solving. I'm going to rub that out because it's not going to form part of our hypothesis. So I'm going to get my calculator up, and I'm going to go to distribution, and I'm going to go to binomial CD, list, and I'm going to put the values from 0 to 15. I'm then going to press equals 15 and the p that we're testing. Right, I now want to find the critical region. So I go down until I see a change from less than to greater than 5%. And I'm going to write them down so I can see it's between 3 and 4. So I'm going to write that the probability of x being less than or equal to 3 and the probability of x being less than 4 are these results. And I can see that I get 0.0, and I need to check clearly 0.0176. And the other one that I get is 0.0592. This is less than 5%, so this is all good. But this is too big. This is bigger than 5%, our significance level up here that we are working at. So this is okay, and this is not. And therefore, we can say that the critical region, which is the values that we would reject the null hypothesis, are the critical region is x is less than or equal to 3. Now, we haven't yet even thought about what happened, and that's really important, that you set up the hypothesis before you actually even think about what happened. But what did happen? Well, 4 came out as red. So observed result was x equal to 4. Now, 4 is greater than or equal to 3. It is not in the critical region. Not in critical region. i.e., it is not unlikely enough. It is not a weird enough result. If we look on the binomial distribution here, you can see that 4 and less is bigger than 5%. It's 3 and less that is the correct, that is in the critical region. 4 does not lie in the critical region. On the screen is the critical region. It's 0, 1, 2, and 3. Those are the results that we would say were sufficiently weird. Therefore, we are going to accept the null hypothesis. We are going to accept H0. We are going to go with, there's not enough evidence to go with H1. We're not going to say that the pack of cards is unlikely. We're going to go with the pack of cards being fair, or at least we think it's fair. And this is the hypothesis test part. So this is the doing the test. Do the test. So what's left? Well, we actually have to conclude. So I always say that this last part is what you're reporting back. So we need to conclude. We need to report back what we found. And what we found is there is not sufficient evidence to say that sufficient evidence, actually I don't need to say, there is not sufficient evidence that the pack of cards is biased against red. Some key points about this. 1, it's in context. So key points about the conclusion. It's in context. It is not assertive. And by not assertive, I mean that I said sufficient evidence. I didn't say that the pack of cards is not biased against red. I said there's not sufficient evidence that that's the case. I didn't say that it is. I didn't say that it isn't. I just said there's evidence that it might be. And these are really important, these two. And this is the last section of the hypothesis test, conclusion. Every hypothesis test should have these 3 parts: the setup, doing the test, and the conclusion. And that's not just true in this chapter, that's going to be any hypothesis test, because there are 2 more hypothesis tests coming in the next, in year 2. Okay, I'm going to do another quick couple of problems. That's your first hypothesis. I'm going to do some more in the coming video. Okay, I'm going to do these examples now, these coming examples, which are a lot like in the textbook section called Finding the Critical Value. They're really focusing just on the finding the critical value part, the critical region part of the hypothesis tests. We're going to come back in the next video to really make some, do some full hypothesis tests. Okay, I'm going to try this problem. I've got my calculator set up, and I have got 0 down to 18 written here, and I've put 18 and 0.4. And I want to see, when does it switch from less than to greater than 5% to find the critical region at the lower end. So I'm looking at the lower end because it's less than. I'm going to get to one that's greater than in a second. And I can see that the probability of x being less than or equal to 3 is equal to 0.0327. And the probability of x being less than or equal to 4 is equal to 0.0941. I looked for the point where it went from less than 5% to greater than 5%. And so I can see that the critical region is x is less than or equal to 3. Now, it asks you for the actual significance of the test here. Now, we actually didn't end up with a 5% critical region. We actually ended up with a 3.3% critical region. So the actual significance of the test is whatever we actually got. And I'm just going to check whether the decimal was exactly right. That should have actually been, and that's an important point, when I hover over this, you can see that it actually rounds to 3.8 here. Ooh, I'm going to make that a bit neater. So let's check my one below as well. And that would have been 4.2. So that's an important point to be careful with, although actually we only need 3 decimal places here, really. Okay, so the actual significance of the test here is going to be 0.30328. So that's the actual significance test, because that's what we ended up with. Okay, let's do another one. Right, I've changed one thing here. I've changed it to greater than. So that means I want to find the top 5%. If you remember from the previous video, we are now doing greater than or equal to. I want to find the top 5%, the values in the top 5%. So I can do it on GeoGebra relatively easily. I can see that the answer is going to be 12 and above, because that gives me 2%, whereas I actually get more than 5% if I do 11 and above. So the answer is going to be 12 and above. So, but let's see how I can do that on the calculator, and let's see how I can do that, what I would need to write down. So I'm going to look on my calculator. I'm going to find where it switches from, it goes over 95%. And I can see that between 10 and 11, that's when it goes over 95%. So I'm going to write that down. And I'm going to leave a gap here. So I'm going to start here. the probability of x being less than or equal to 10 is equal to, and the probability of x is less than or equal to 11 is equal to. That's where it switches over. But I don't want them. I want greater than or equal to. So how do you switch a less than or equal to a greater than or equal to? You do 1 minus. Now 1 minus 10 is actually equal to, x is greater than or equal to, so 1 minus less than or equal to 10 is actually greater than or equal to, draw my little number line, 9, 10, 11, 12. Less than or equal to 10 is this, so we actually get greater than or equal to 11. 9, 10, 11, 12. Less than or equal to 11 is actually greater than or equal to 12. So I get that there. Please do this every time. It's the only way to not make a mistake. And now I can write down my values from here. 0.9424 and my value here 0.9797. Right, if I want to do 1 minus those values, you can actually use the calculator to store these values. So store the value on the screen, store that as A. And if I go to this one, I can store that as B. Go into the main screen. 1 minus A is 0.0576. So 0.0576. And 1 minus B, 0.0203. And that has been enough concluding evidence to say that this is greater than 5%, so that's no good, and this is less than 5%, so that is okay. And that means we have ended up with a critical region of x is greater than or equal to 12, as I said that we would get. And what's the actual significance of the test? Well, it's not 5%, it's this, so it's 0.0203. Okay, next question. Okay, we've got a new symbol here. So this new symbol is saying not equal to. And what that means is that when I look at my binomial distribution, I actually am saying I don't care whether it's at the bottom end or the top end. Instead, I'm going to be testing, is it just not in the middle? So is it either in the middle or not in the middle? So I need to consider both ends. And so the key point here is that what we do is we split the significance level. So what we do, if you imagine this is my binomial distribution, is what we're going to do is we're going to put a critical region at the bottom and the top, and we're going to say that it is 2.5% at each end. So a two-tail test, this is called a two-tail test because we are looking at both ends. All you do is just do 2 one-tail tests, one at each end of 2.5%. I'm definitely going to need a little bit more space. So we have to do this twice. We have to do a less than or equal to test at the bottom and a greater than or equal to test at the top, but instead half the significance level, So at the bottom end, we're going to do a test. So let's go back into my distribution and let's hope it's still there. Fingers crossed. No, it's not. So we're doing 18, 0, 1, 2, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And we want it to be 18 and 0.4. There we go. Right, so I need to look at the top and the bottom end. So lower tail. Probability of x being less than or equal to something, and the probability of x being less than or equal to something is going to go from greater than to less than 2.5%. And I can see that goes from 2 to 3, 2 to 3. So this is 0.0082. And this is, I'm going to check my numbers this time, 82 and 328. And that is my correct thing. I'm just going to check that my values are definitely right. Are we talking about the right values? 328, yeah, good. And this is less than 2.5%. And this is greater than 2.5%. So x less than or equal to 2 is going to be the lower part. And now we need to do the same again in the upper tail. So it's exactly like the previous example. Again, I'm going to leave a space because I'm going to want x is greater than or equal to something. I'm going to write probability of x is greater than or equal to something. And that's going to be 1 minus the probability of x being less than or equal to something, and 1 minus the probability of x is minus or something. And now I'm going to choose these numbers such that, see, I've already set it up. I haven't even looked at the calculator. I'm going to choose these numbers here such that I go above and below 95. So we're going to go down 97.5%, because we've got 2.5%. So 97.5% is what we're interested in. And that's there. So I can see it goes between 10 and 11. So I'm going to put 10 here and 11 here. And those values are 0.9424, and this value is 9797. Now, what are these values going to end up being on this end? Well, I can see that greater than or equal to, less than or equal to 10. So I'm going to write my little number line, 9, 10, 11, 12. Less than or equal to 10 is going to be greater than or equal to 11. Less than or equal to 11 is going to be greater than or equal to 12. Now, actually, at this point, you may have spotted the trick. If you look in a calculator and you see that the change happens between 10 and 11, the answer is going to be 12. 10 and 11, and you're going to get 12. And that is a trick. You go one more. You find the switch and you go one more. And that is true. And I can actually think that those are the same numbers that I had before, 576 and 203. 0.0576, 0.0203. And this is greater than 2.5%, and this is less than 2.5%. And so the critical region overall is x is less than or equal to 2, or x is greater than or equal to 12. So we just kind of combine these two things together. It is less than or equal to 2 or greater than or equal to 12, and that's the critical region. There's one bit at each end. Now, write down the actual significance of the test. Well, we've got 2 bits, so we need to add them up. We've got 2 bits, so we need to add them up. So it's going to be the part for 0.0082 for the lower tail, plus the part that we ended up with in the top tail, 0.0203. And so overall, I can see that the actual significance of the test is 0.0285, which is not 5%. It's about 2.9%. So we can see that by having to trap the critical region less than 2.5% into each end, we've actually got quite a lot less than 5% here. But nevertheless, it is okay. Which brings me to the final point, the final bit of this. And that is that sometimes you're asked to make the probability in each tail. So this is exactly the same as the previous page, except for it's asking for the probability in each tail to be as close as possible to 0.025. I'm not going to do this on the calculator, but you can. What I mean, actually, I will do it on the calculator. What you need to do is to make each end as close to. It doesn't matter if it's slightly more. So at the bottom end here, I'm just going to have a look at the top end. At the bottom end here, we can see that there's not going to make any difference. I'm just going to write an explanation. 0.03. Oh no, it does make a difference. It does make a difference. My bad. Okay, let's go back. So probability of x is less than or equal to 2 we had was 0.082. And the probability of x is less than or equal to 3 is equal to 0.0327. This is closer to 2.5%. So we're going to take that one instead. And at the top end, you can actually see that so the closest one is this one, which is going to stay the same. So when we go back to the previous page, you can see that this is closer to 2.5% than this would be. So I'm just comparing these. So this is actually closer to 2.5% than this, and this is closer than 2.5% than this. So we're actually going to end up with the critical region here being actually, what I'm going to do to make this really clear is I'm going to copy this across and then edit it to be the new rule of wanting to be as close as possible. Okay, so I'm going to go onto this page. Okay, so what we actually had in the previous case, I'm going to delete one of that. In the previous case, this is what we decided, but some of this is not correct. So if I rub out these two things and I rub out this final answer, let's see what we actually come up with. So everything's the same, except I am now going to choose this one as it is closer. So my answer is going to be that this is the final answer. So I'm going to take less than or equal to 3. And in this case, it's still the same one. This is closer and this is not. So I'm going to choose this. So the answer is the same at the top end, still greater than or equal to 12, but at the bottom end, it's less than or equal to 3 now, not 2, because it ends up being closer. Now this does mean that it could go over 5%, but it might be a better test. So what is the actual significance of the test? It's going to be 0.0328 plus 0.0203. And so this is our actual significance of the test, which is 0.0533. So it is greater than 5%, but it's a much better than in the previous case. It's much better than in the previous case. Okay, I am going to let you practice some questions now. So I recommend you try these questions. Exercise 7A is just kind of a bit about hypothesis testing. Definitely read the textbook as well. Exercise 7B is where we're practicing those last kind of questions I was doing. And I'm going to recommend you have a go at this question. It's a hypothesis test, just really closely modeling it on the way that I did our first hypothesis test. In the next video, I'm going to just be going straight into doing examples of hypothesis testing. Okay, I hope that's been helpful.